good evening, good morning, depends on where you are. And Happy Mother's Day. And yeah, thanks for allocating time to join us on this webinar. My name is Zen Zhang, and I'm a database consultant working for AWS. Here, this presentation is about execution plan and how to read them. And so after this presentation, I believe that you all have a confidence to go ahead to use the knowledge we learned today to your day-to-day work. Just like every the other languages, execute execution plan. The plan is the language, right? So kind of like a map, right? So nowadays, people use the GPS, but before the GPS, so what you do, you in the new cities, right? You need to buy a map and use the map to tell you where you are, right? So the plan is also the map, right? In order to so let's start it. In order to, here is the three parts we are going to cover today, and I will leave enough time for you for the Q&A time. So the first is where are we? The we means that where is the execution plan, and where is that in the overview of the architect? Where is the belong to, right? And then I'll give you an introduction of the execution plan, 101, regarding like how to read them, how to turn them on, and such and such, right? And then we'll dive deep on the reading plan. I believe that the best thing to learn is that to give a try, right? So I will give a demo using my local SQL Server 2019. You don't need to be a 2019. You can be as long as it's a SQL Server 2005. You should be enough. There is a little bit of change since 2005. However, regarding the how many operators, I believe on 2019, 2000 up to 2017, we have about 79 operators inside the plan, and but you don't need to know all of them. I summarize about dozens of icon, which is we call the iterator/operator. I believe those are most common operators. Okay, so the first thing is that on the overview, where is the plan, right? So the plan is on the left side. As you can see, that the optimizer, it is the optimizer that to generate this plan. So the operator is the optimizer. Optimizer is belong to the query processor. And after this plan is done, right? After this plan is done, it passed to this this query processor is belong to the relation engine, right? After this done, this is the query plan has been generated. It is a binary as a format. It is a binary, right? After that, the query plan was pushed to the storage engine, where all those for example, the fetching the data, how to search to go by either index or by whatever the plan guided to get the data. That is a storage engine's part. And the first from the beginning is that we have a query, right? Either you use a client tool or application, you submit this query to SQL Server. And then there is a parsing. The parsing means that if you, I believe all of you, if you use SQL Server daily, you use Management Studio, right? And Management Studio, when you type a query, there is a check mark on the toolbar, and that is a parsing, right? The parsing will make sure that you are error-free on syntax-wise, right? After the parsing, there will be passed to another components to process this process called algebraizer. Algebraizer is that means to locate each of the objects and make sure that objects has a valid objects, right? So internally, for example, if I have a table called user, right, and the algebraizer will make sure the user has a right schema, which is that for example, you have a schema of a user, users, and under the schema you have a user table, right? And also on top of the owner of the user, you have a database called, for example, my database, MyDB, right? That is algebra. Algebra will guarantee that, make sure that each of the name is fully presented, right? After that, that is and next is called the query processor tree. The processor tree is the format that the query optimizer will recognize, and after that, the query optimizer will generate the plan. The plan, as I said before, is a binary, right? So it will use all the statistics to help to guide the plan. So that's why you hear a lot of time the DBA said that it is important to have your statistics up to date. Otherwise, you get the wrong plan. So why is that important, right? Because that for SQL Server, right, there is a algorithm inside their code to trigger the process to update the statistics, right? The function is 500 plus the 10% of the total row. So what I mean is that even, for example, if I have a 1,000 rows table, right? And if I change the 500 plus the 10%, that is the 600 rows. If I have 600 rows changed, that will trigger the process to update the statistics, right? So, but if I only have a 10 record change, this statistic will not change, right? So that's the statistics is kind of like internally, it's it tell you how what is the distribution of your table, right? For example, if I have a product table, there is a product. It tell me, and if I have a statistics on the product name, right? The product name will tell you that how many, like for example, how many rows, how many records the product starting with A, right? How many start with B, right? That is the distribution. Based on that, this will pass to the optimizer to generate the plan. Why is that important? For example, if I have a 1 million rows, right, for the product, I have many products, and for if you have like 90%, it's so weird that 90% of your product starting with A, and then that is the statics. When the query, when the optimizer found that 90% of your rows start at the product name starting with A, and you are looking for some of the name is A%, right? For example, that will tell the optimal plan is that I'm going to use the index scan. Why? Because the index scan is much efficient than the index seek, right? But however, if I have a statistics and also I have a product starting with a Z, right? There is a few names start with Z in English words, right? So that means that if I search select start from the product where the product name equal to Z%, that's and the distribution tell me that I only have like 1% of the records starting with Z. In that case, the optimizer will decide to use the index seek instead of index scan. So again, the stat is so important. That's why sometimes when we see a old stale statistics, we will get a wrong plan, right? One of the things that I will show you, just remember, I will show you is that when you can see your status is old, because when you run the query with actual execution plan, you will see that there is a item called estimate row return, and also you will see actual row return. Sometimes if there is the two number, this is the number, means that how many rows will be returned, right? The first one is estimated, the second one is actually returned. If the two number are different very much, that means they were using the wrong statistics, okay? So that's why statistics is important to generate the plan. Okay. Now, let's dive into the very basic of execution plan, right? Okay. The first thing is that I want to make sure you understand that the plan was generated based on the cost, right? So the optimizer will try to, within a limited time, to find a good enough plan with the lowest lowest plan. So as long as they consider this is good enough, it will return the plan. So here is a keyword, is good enough, right? Because you don't want the your time, when users submit a query, you don't want the user waiting and to find the best one, the best execution plan, especially that for the data warehouse environment, that you will have a more than it's not uncommon to have a 20 tables in your query, in your search procedure, right? And it is sometimes it is hard for the optimizer to evaluate each of the possibilities and come up with a plan. In that case, the optimizer just pick up the one that they think it is good enough. Okay, so I already talked about the how important of the statistics. Another thing is that so the plan is saved in the plan cache. The plan cache is a special area in the memory that to hold the plan, right? But this plan is not saved for good, right? So sometimes because the memory have a limited space, they cannot be saved for good in that memory. Sometimes they have an internal routine job to check each of the plan to see if it is old enough to be flashed out. So that is called age. So how can we decide the age? The age there is internally in their code is that to equal to the cost of the concept being used. So what I mean is that I have a query, right? The total cost of the query is 100, right? And I have 5 time being used. So that is so the age is 500. Every time there is a internal routines to check, it will minus the value to 1. So when it is the age is equal to 0, it's time to flash this part out so leave a space for new plan to come in. Okay. On the right side, there is a query that I used a lot to get the what is inside currently inside my plan cache, what is the execution plan cached, and what is the statement associated with that, and what is planned belong to, right? Belong to which database. You don't need to write it down. I'm going to share with you these slides with this script as well. Okay, so that's a script. That's a script I use a lot whenever I want to see that currently how many what kind of a plan I have in memory, and what is a statement looks like. Okay. Another thing is that when we read the plan, so how can we read that? It's always remember is that you read that from right to left, and from upper to the bottom. That is the and also, so I will show you in the demo. But for each of the step, there is details called property of these steps. You can see the one item called subtree cost. That subtree cost means until now, including this step and including all the steps before, what is the cost would be, right? For example, here, if I have the subtree cost is 100, and here you will see 200. That means this one is 200, and before this step, there is total is 100. That's what I mean by subtree. Okay. Another very important thing idea is about the estimate plan and the actual plan. The only difference is that the estimate plan will not be run, will not carry out, right? And it's just estimate. And actual plan means that it is a real one. So if you want to see how many rows really return, for example, you had to use actual plan. Otherwise, you need to use estimate plan. And when you use the actual plan, execution plan, one important thing that to remember is that it is really running, right? For example, if you have a statement of update or delete, you want to be very careful. Right? One of the usual way to do that is that I will start a transaction and then I will see those execution plan, and after I display the plan, I will roll back. That is one way, right? Another thing to notice that the query. So usually speaking, one query will map into one execution plan. However, for the data warehouse or for any environment, if you have a multi-core and if you have a setting that the SQL Server think that there are two settings to decide whether or not you need to have a parallel execution plan. So what is the benefit of the parallel execution plan was that it will multi-core, and the multi-core will work in parallel to get the data, right? And you can imagine there must be some benefit of using the parallelism. However, there is a cost as well. That's why if you use SharePoint in your company, you will notice that the SharePoint always ask you to run in single thread. The SharePoint, all the query, SharePoint use a SQL Server, right? So all the interaction between the SharePoint application and the SQL Server, they require to run in single thread. Okay? There is a reason. and sometimes it is faster using one single core instead of using multiple one. Why that? Because you can think about, if I have 4 people to work with me, right? Work for me, and I distribute the task into the 4 people, and if they can work in parallel, sometimes it's faster. However, if I have one worker, maybe his work slower than the other 3, so all those other 3 had been waiting for the slower one to finish. And it's better in this case. It's better to just distribute my workload to the fastest worker, right? So that is one thing to keep in mind, is that when the SQL Server consider I can get benefit by running in parallel, so the query will be generated 2 plan, and those 2 execution plan will all save in the plan cache. Okay, another thing, one of the quick benefit I want to point it out is that why we need to learn the plan is that the plan will tell you a lot of things that you contradict your thinking. For example, you can see here. I'm not sure if it's too small. Maybe let me enlarge this. As you can see, this one, this is the query, right? This is the query. It's a very simple query. It's a delete, right? But as you can see, this delete, if you see the plan, you will notice that there is a lot of things happen. Not only they need to delete this product model, one record, right? But they need to go to all other tables. Why is that? Because there is a foreign key related to this table. So they need to, for example, they need to go, they will incur a cluster seek, right? The cluster seek is that it will took other tables to make sure that other table also have this record. If they have this record and your foreign key was defined to cascade deleting, then every record, associated record in the other table will be deleted as well, right? And also this one, before our demo, it is also good to notice that each of the icon are represented as a operator, right? So you can see that there is from my right side, there is a cluster index delete, right? So that's the icon, and the cluster scan, that is another one, and the nested loop. So what is the nested loop mean is that the nested loop have a inner loop and the outer loop, right? On the outer loop, always on the bottom side, and the inner loop is above it's the inner loop. So what happened is that they will use the outer table to drive the inner table. As you can imagine, that if the outer table have a high volume of rows, and then this will make the nested loop not efficient at all, right? So on the contrary, if you have a very small rows in your outer table, right, and the drive to the inner table, then it will be much faster. Okay. So any questions? I want to make sure this is more interactive. If you have questions, please type it to the chat window. Sarah can pass those questions to me, okay? Or you can just talk and stop me.
Yeah, I haven't seen any at this point, but when you were saying use the smaller one as the outside and the large table the inside, how would you write the query? Can you give an example? Like
Yeah, sure. So the thing is that when you run when you use a nested loop, right? You want to have usually it's two tables, right? The two tables. You want to make sure that the two tables, one of them will return a smaller data set. Another one will return. Another one can be large, but you don't want to put yourself in a scenario is that both of the table have a very high rows. That means that it is not efficient to use nested loops.
okay. So somebody mentioned that we only see your slide deck, but is that the one you're sharing right now? We can only see execution plan 101.
Yeah.
Okay.
Yeah. I'm going to after this. I'm going to have a demo now.
Oh,
okay.
Wonderful. Cool.
Okay.
Thank you.
All right. Cool. Now, let me give you some demo. Okay. Now let me switch to my another window. Okay. How can I resharing? Let me see.
Would you be able to move the
Sorry
one
about
over?
that. Let me see. Oh, I see that here. Okay. Open share tree. Do it again. Yeah, I saw that. It's just too slow. Okay, 1 second. No, I'm sharing my management studio. Can everyone see it? Sarah, can you confirm you can see it?
I can see it on my on the as a host, but on the other end, it seems like there's like about almost 30-second delay.
Yeah.
Yeah. So whenever you point at the stuff, and it's probably gonna take the audience about 30 seconds to see it.
I see. I see. How about now?
We probably need to wait a little bit. Right now, it still says the live event will continue in a moment.
Wow. Yeah, the team show me.
They can see now.
Okay.
So I guess maybe it's my end. It's kind of slow.
Okay. All right. Okay. Cool. So here is that several queries that to show the idea of the plan, right? So one of the things that first thing is that when you have a plan, when you have a query, you want to see the estimate one, you can do Control L, right? Control L will, yeah, first thing, of course, I need to connect it. I need to switch. So when I type Control L, that will be that will display. I hope everyone can see the execution plan. Control L, that is will display the estimate plan, right? As you can see, there are two operators, right? One is cluster scan and the other one is select, right? So, and also when I right click on this one, there will be some interesting data here. As you can see, this one said I have a logical plan, logical operation and the physical operation. Here is that they are the same. They all belong to the index scan, right? And also it can tell us that the estimate the subtree cost. The subtree cost is that these steps, because there's no previous one, so these steps will cost about 0.07. So this is the number. Is the number itself has no meaning, right? It's only about the comparison number. That is meaning, right? So here another way to see that is that even you see, for example, the cost is 0, it is not mean 0. It means that compared, it's just comparably, it is very low, very low. That is why it has 0. Okay, but does not mean it is really a 0, right? And
sorry to interrupt.
okay.
Is that possible to make it a little bit bigger? Because
Sure.
they were saying it's hard to see the cost percentage.
Yeah. Okay. How about now? The better?
I couldn't see it still.
Mm.
Well, if you can, but that's fine.
But can you see the screen? Now it's larger.
Oh, okay. Let me see if they said anything. Yeah, they're still saying it's kind of small to see, but well, cause mine has like a 30-second delay, so right now it's still showing the previous moment, so I can't tell right now. Give me a sec. Well, that's okay. Just continue. Sorry.
Okay. Yeah, sorry about that. My first time to use this. Let me see. Okay, how about now? Yeah, so I apologize for those of you cannot see it, but so the way that to right click on this operator, you will have a attributes here that will show you the most some of the interesting item, right? For example, we can see that estimate row return, right? That is 295. That is just tell me estimate. But what if I want to see this value, right? I want to do to choose this one to I want to see to display the actual plan, and then when I run this, so there is a difference, as you can see. Let me enlarge this one. as you can see here, the compared to the estimate one, you can see now we have a several four items called actual, right? One is called actual number of rows, right? That is 295, and above this actual number of rows, there is another one called estimate rows return. The estimate return is also 295. That tells me that my current stats 100% reflected the real scenario. Okay. Another thing that I want to point it out here is that there is a actual rewinds and the actual rebands. So those value are directly connected to the source code. So what that means is that every time the related objects are being checked, and it will call a function called init, right? Init. The init. So every time it call init, this value will add one. Okay. But for you to use this one, just remember the lower number, the better. Okay. So here is that actual rewinds and actual rebands, they all 0. It's good. If you see a high value, of those two, there will be issue. Okay. Now, let's see another one, right? So I'm continue use display the actual execution plan, and as you can see, this one I'm going to search a one single table with I'm going to use the product number as a where clause, right? As you can see here, here is that I'm using the index seek. So why I'm using the index seek? Because this is, look at that. This is the index, right? I'm going to use this index called product name, right? It's a product number, right? So as you can see, this product number, there is a seek predicate. The seek predicate is that use the number, and also there is interesting thing here is that in the last line of this yellow little window, it said there is a @1. So apparently this @1 is a parameter. You know, as you can see, this is my query. I didn't declare the parameter. Why there is one called parameter? Here is that the query engine will they think they will use the parameterization optimization. Right? What that means is that they want to whenever they see the constant value in the where clause, they will think maybe in the future that this execution plan can be reused by other query that have a different value of the product name here, right? So that's why here they just declare create a parameter, so it will save this plan. So the next time when someone use other value but a similar query, it will be this plan can be reused. That's why you see this @1 here. Okay, and why another question is that why here is that we use index seek instead of index scan. Is that because the query engine, based on the value, based on the statistics, the value will it said maybe to use index seek is more efficient. That's why it choose to use the index seek. Okay. Here is another interesting thing about use the non-cluster seek, right? So what? See, this one is use cluster seek. Maybe I put it wrong. Let me go here. Key lookup. All right. All right. Okay. Here is that I'm going. Let me see. Zoom fit. Okay. I hope this is better. So here is that I have a for operator, and as you can see, this one's called key lookup. Why is it use a key lookup? The here is that the thing that because when there is no whenever you see the key lookup, that tells you that you do not have a covered index. So what does that mean by covered index? Is that when the query, right, inside the index, it is a B plus tree, right? And if the query can find all the needed value without go back to the table to find extra value, that is a index we call a covered index. For example, give you another example here. I have a index on this product number. However, this index only have one column on product number, but I do not include the color column and the list column. So what I'm going to do is that I'm using the non-cluster index because product number is not my cluster index. The first thing that I'm going to use index seek to find out all the records that has a product number equal to this value. And then by doing that, I also get my cluster index key, right, which is the product ID. And then I'm using this product ID column to go back to the table and using this key to looking for the other two columns. That is called a key lookup. As you can see, the benefit of the reading this plan is that I can tell that it is not efficient, and also I know how to handle this this issue by creating a covered index. Okay, and here's another one I want to show you is that here. Okay, here is that I have, you notice that this one, I do not have a where clause. So when I do not have a where clause, what happened? I have more data, right? So that is a very common for happen on the developer's code is that they think that sometimes it is, some developers tell me that it is more efficient to return all the rows back to the application, to the code, instead of adding a where clause, which is not true. The reason is that the more data you need to get from the database, the more time you will spend on network, on disk I/O, because you can not guarantee that all the data is inside your memory, right? Sometimes if the data is not in memory, will incur a disk I/O. The disk I/O is the most slowest part in the plan, in the operation, right? So that's why we do not recommend that you without a where clause. You definitely want to have a where clause. Okay? And another thing that to notice this one is that after this scan, we need to have a sort. Why is sort here? Because here is a merge join. The merge join means that they will take two different data source, right? And each of the data source must be pre-ordered. That is the only reason you can use merge join here. So they will merge two ordered data sets into one. That is the merge join. If your data is not ordered, you cannot use merge join, you can use hash join, okay, which is another operator called hash join, okay. And also you can see here is that there is a warning, right? So the warning said the query memory detected excessive grant, which may impact the reliability, right? What that means is that you you returned more data than you needed, right? So that is what this explanation means, okay? So as you can see, to do the comparison here, I add this where clause, and let's see what happened, right? You see the difference? Now, as you can see,
Hey Zen, I think you're froze on your end. Sorry about that. I think he's rejoining.
all right, okay, I apologize. I was disconnected. I don't know what happened. I'm not sure if it is because of this team issue. Sarah, can you hear me?
Yeah, I can hear you.
Okay, can you see my screen?
Yeah, it says welcome to Teams. Is that what you're sharing right now?
Let me do stop sharing. Reshare again. Okay. Can you see my screen now?
Yes.
Okay, apologize. Yeah, I think I was disconnected here. Is that I show you that we were using the query without a where clause, and that will incur a index scan and will incur a sort. Why we have a sort? Because the plan was decided. Can you hear me? Hello?
Yeah, you're fine. I just
Okay.
mute
All
myself.
right. Okay. All right. So this is because the merge join here, the merge join here, they require to have larger. the merge join require all the data source to be pre-sorted. That's why there is a sort before the merge join, right? However, to compare, if I have this where clause, as you can see, my plan changed much better, right? So now I have a index seek and I have index scan, and all the value here are pre-sorted. Because why? Because I already have index. If I have index, all the data is pre-sorted, right? So here is that I can use instead of use the merge, I use the nested loop. The benefit, as I said before, is that if the nested loop have a inner table and outer table, and here is that I have one of them is a smaller table, so use the nested loop will be faster to return the record. Okay. Next one. Okay. Here is another example to show you that why sometimes the different operator you choose will impact your performance. Here is that one thing that you want to look at is this percentage, right? So when you have a slowest slower query, right? When you study the plan, you want to see that the percentage. You want to starting with addressing those with a larger percentage. That means is that again, it is the value is not important. The comparable is important. Here is that I have a 173% percentage of the time spending on the merge join. So I need to work hard to remove this merge join. Why there is a merge join? Because I don't have a where clause, right? There is so many data. There's the optimizer decided to use merge join to return the rows. Here is that I want to remove them. How can I remove them? Add a where clause, right? So here is that a very brief introduction of how to read the execution plan, and what is execution plan to relate to our performance. As you can see that those performance, the meaning and how which operator to choose is highly depends on the knowledge, your knowledge of the performance tunings, right? So some of the basic knowledge I didn't cover today because I assume that you already have one. For example, you know that whenever you have a index scan, you might want to change them to index seek, right? So whenever you saw you have a merge join, you realize that before the merge join, all the data need to be sorted. However, if you have a data that you query, the column was not have an index, then your data is not sorted. In that way, before you reach to the merge join operator, you need to have an extra step called sort, which will definitely cause you delay your query, because the sort happened inside memory or inside the disk if your memory is not enough. So that is the benefit to understand the plan, and based on the operator you saw, you can clearly identify the operator, the direction you need to work on. So I hope that you learn something about the plan. There is more, since I really cannot cover them within 1 hour. To be honest, this is about it's a 1 week training contents about the execution plan. One of there is some advanced topic I didn't talk about it, such as to use the plan hints, right? Not only the statement SQL hints, you can use the plan hints. How to rewrite your query to get a better plan. Those things I don't have time to talk about it, but I will provide the link if you have interest to learn more about this. I will send you the link with the slides as well to Sarah, and Sarah can distribute to our to all the attendees. All right, that's it for today. So this is now I'm open to question.
Yeah. Oh, thank you so much for sharing this. It's a very helpful, great content.
Thank you.
Yeah, we got this question saying that the sorting, the indexing of the tables used in a query, how does choice of indexed columns work? We probably have to think through which table columns to index, right?
Would you mind to repeat your question?
Let me see. Hey, Frank, would you be able to, did I mute everybody? Would you be able to answer the question yourself? Are you still there? Well, basically, if I understand it correctly, so he was wondering how does the choice of index columns work?
Oh, I see. So the indexing, the index is a way to speed up the query, to identify the query, the records you want to find, right? For example, here, okay. For example, here, I have a query that to looking for all the records from a product table with this product number equal to this value, right? So let's say if I do not have a index on this table, I don't have any index on this table, what the execution plan will do? Because there is no index, the plan will choose the table scan, right? So why they choose the table scan? Because this is more efficient, we think, instead of to looking for row by row. That it will do a scan. Every time a scan will scan, every time it will read 8K pages. And that this, if the row is only a couple of thousand rows, it can quickly read all of them into memory, right? That is, however, if I have a billions of rows, this one will take forever, right? So that's why I said, when you see this, you want to ask yourself, do we have a index on this product number? Number one. Number two is that, do we have a covered index? What that means is that when I see, the index is the data, okay? So when I have a covered index, means I use the index to find the records. I don't need to go back to the table to find extra column value, because if I have a covered index, this index will including not only the product number, but also the color and the list price. So there is no key lookup operations on the plan. I hope that answers the question.
Yeah. So he rewrote the question and saying that if you want to join two tables in a query, it helps to have them indexed, right? So if the tables have many columns, you probably can't index every single column.
Right. That's true.
Yeah.
So one thing is that that depends again. It depends on your business request, right? Usually speaking, for example, if I have this two, right? I join them. And if this is frequent, you see many of other queries, not the same query, but they all rely on the relationship between these two tables. You want to consider to have a index on the joined on this on column, right? So that will definitely most cases will improve your performance.
Yeah, yeah, I guess the issue here is that, if you have two tables that they both are really large, meaning that they have many, like, maybe billions of rows or something, and also the table itself, themselves are very wide, meaning that they have many columns, but in that case, um, it's pretty difficult, especially it doesn't have it doesn't have one unique column. You can use it as a, to set as a primary key. And in order to do a primary key, you probably have to combine quite a few columns to do that. Then in that case, when
yeah, I
when
got
you
it.
join them, yeah.
Yeah. So here is the thing that again it depends on the data, right? So you really don't have a luxury to including everyone. Make every of your query using the covered index. But think about this: if even though you do not have a covered index, however, for example, in this, each table have a billions of rows. However, I know by using this query, and this one only return about 200 rows, right? 200 results, 200 rows of results. So 200 results even go back to use the key to find extra other columns. It will not cost you much time, right? In that case, I will live with it for this key lookup. However, this record, for example, if it's a category ID equal to 10, it will return 100 million rows. And then the key lookup is very expensive. In that case, you want to including all the columns, make the covered index. That's number one. Number two, you have to think about this, right? If your table is comparably very static table, right? So you can then, I would say, create more indexes, and you use the space. You had to provide more spaces, because you do not, static means that you do not have update delete, right? In that case, you see, I will spend more storage space, and then I will make my query faster. However, when you think about most of the cases, we do not have a static data. Our table also being updated a lot. In that case, you want to be careful to create index, because every indexes when there is a change, for example, this one, right? As you can see, this one, for every time there is a change, there will be incur a lot of operations, right? So the more index, the more work the table need to do, especially when you delete a row, and that will cause the cluster index to be rearranged. So in that case, I will first to realize that the more index not only occupy more disk space, but also delay my query, right? And the third thing I want to add to comment is that if you have a query that is not important, number one, not important, number two, not run often, only like run once a month, do you need to optimize this, right? If your boss said this is important to them, yeah, you had to try to trade in other considerations. But if it's not important, let it run slow, right? Because you have to consider other things. You don't want to lose. You don't want to create more issue to other updates process. For example, in order to make to create a extra index and make this specific query run faster. There's a lot of considerations you had to pick up. You had to pick up which one is important to you.
Okay. So continuing that question. So when you have a query, which columns would you choose to when you create an index, say like a non-cluster index?
Mm-hmm. So the thing is that when you have a index, when you have a table, right? So how you pick up which column A, B should be your primary one. So which column should be your non-cluster index? That's a good question. And there is I don't have time to talk in detail about that, but whatever you pick up the column as your primary index, the cluster index. You want to make sure this cluster index does not change too much, right? Because the change on the cluster index column is more expensive than the non-cluster index column. The reason why is that all the non-cluster indexes rely on the value, the pointer on the cluster column. If the class column change, all other non-class index need to be changed. Right? So that's one of the consideration, right? You do not want to pick up the column that changed very frequently. You do not want to pick up those column as your primary one. And another thing to consider is that you do not want to pick up a column that use for example, I saw many developers choose a unique ID column as the primary index column. Well, you can argue this will guarantee that you have only single one. However, you have to think about the best of the primary column candidates is those have a continuous value with a very narrow type. So what that means is that, for example, if I have a integer, right? Integer is 4 bytes in SQL Server, right? And the UUID is 16 bytes. Why, what's the big deal? Well, if you only have thousands of rows, it's not a big deal. If you have a 10 million, 100 million rows, the difference is 100 million times 4 bytes. That is the cost of the storage. And also remember that for every non-cluster index, it automatically include a primary, the cluster index in the end, right? So what that means is that, for example, if I have index on product number, but my cluster index is product ID, this value, the index after this product number will be including this primary cluster index. So that's why you can see why I don't want to have a very large data type to use as my primary index, my cluster index. I'm sorry. Yeah, I hope that answers the question.
Thank you. So in other words, if there's a unique, like a unique identifier versus integer column, then you would rather choose the integer one over the unique identifier. Okay.
Yeah, that's the most reason is because the unique identifier, the UUID, caused a fragmentation. That is a hurt for the query performance. Why it hurt? Why it's caused a fragmentation? Because the number cannot be ordered, right? So if you insert the rows, those indexes it's very hard to get ordered because the UUID every value is different.
Would you be able to use the unique identifier column in a non-cluster index?
You can. However, that again, it depends on what's the benefit you can get, right? One of the common way, so that, for example, if you need to use the UUID, right? So one of the common ways that when I design the table, I can have a UUID column, and then I can have, for example, I can use a CRC 32 function in SQL Server. I know there is a third party to or use hash function to get a value. For example, the value, and then this value will be mapped into this UUID. This is another way to dealing with UUID column. But to answer your question directly, is that depends on how you use your data, your data access pattern, right? If you see the benefit, use the UUID as a non-cluster index. Yeah, use it as a non-cluster index.
Cool, thank you. Is there any more questions from the audience? Okay, I got another one for you. So when you design the index, for those tables that get frequently updated, say like every 15 minutes, every 30 minutes or so, is that beneficial to drop the index then like the non-cluster ones, and load the data, then re-index, or you just leave it as is, then run some refresh later on?
Good question. That depends on the column. Usually, it's not a good idea to drop them and rebuild them. The reason is that although the SQL Server provides you the options to recreate the index online, however, that will impact your query performance when you query on table. That while this table this column has been used to access the data, and this index being rebuilt, that will cost you extra disk I/O, and your performance will be affected, right? When I say usually it's not a good idea, it also depends on your business usages, right? So for example, if you have a large table, right, you want to you have a daily loading process every time you're loading a high volume data. When you loading the data, if you have can afford to have like a maintenance time window, right? So you can for example, you do that during the midnight, and few access will be needed, will be initiated from the application side access this table. In that case, most common practice is that create a process before you load in the data, drop all the non-cluster index, and then after you done, recreate, rebuild those indexes. Yeah, but again, it depends. Depends if you have this window, right? And if you do, and you can finish the rebuilding. Yeah, do that way.
But what if you have to frequently update the, like do the incremental loading throughout the day?
Okay, in that case, I would say that you had to think about first. Do not use this column as a cluster column, a class index column. Use this as a non-class index column. Right. So that is related to the design. When you design, you really do not want to pick up a column that will get updated frequently. Otherwise, you will have a very bad fragmentation.
Mm-hmm. But if you have to refresh, well, not refresh, just import the data many times during the day, and when would be the best time to re-index, or do you really need to index every single time?
The one thing is that to make very clear is that what is the purpose of the reindex? The purpose of the doing the reindex is that to make to make the index to be more consolidated. Another way to say to less fragmented, or to make the stats associated with index up to date. What is important? The answer is that the more important thing is not to defragment it, right? The most important thing is to make this statistics on this column up to date. This is more important, right? I saw a table that have a 4 terabytes of the table that they cannot afford to do the entry index. However, they can do a update status only. Okay, so that is the thing. If you have a business that you cannot you had to frequently update the data, right? So by design, if you are unlucky to pick up the column that need to be updated by design, right? You have to face in the issue of the fragmentation. However, the fragmentation will say is that when you do a query, there will be more disk I/O, right? Because when the SQL Server reads the data, they will do a pre-read, which means that when they fetch the data, not only this page, but all the continuous page before and after, they will fetch together. However, if you have a highly fragmented table, then the one fetch will not grab as much as useful data. In that case, right? So your query will incur a duplicate, many unnecessary round of disk I/O. However, that is not comparing to a outdated statistics. This is not as important as your outdated statistics, because when you have a old statistics, you will not generate right plan. That is more severe than the fragmentation.
Then in that case, does it mean you need to update the statistics every time you import data, or how often you should update your statistics?
The statistics will be, remember in the beginning I said, there is functions to decide it. The SQL Server internally have a process to update statistics, right? Every time you see in the table the statistics folder on the left side, you will see, for example, here, I'm still sharing my window. So this is not good. How about this one? Here. See those one? That's the WA. That means Washington. This is internal. This is the naming is from the very beginning of the SQL Server. So if I click copy, so what I want to say is that every time this underscore WA underscore sys, that is generated by the engine. Every time the column being accessed, right? If the stats is not there, the SQL Server will automatically create one. Okay, that's one thing. Another thing is that there is a function inside the SQL Server to decide it when to trigger the auto update statistics process. So the equation is that 500 rows plus a 10% or 15%. I cannot remember clearly. I think it's a 15%. 500 rows plus the 15% of the total rows. If your rows change above this threshold, that the internal status or update will be triggered. Here is a quick see this one, right? This is a table, and there is no there is the reason why they have a WA-sys is that WA-sys means Washington, right? So Washington State. That is the one is generated when this column product category ID was accessed, and the SQL Server will consider having this statistics will help on the query. So that's why it generated this one. It's generated by the system. As you can see, you can read this. This one is update status. Okay.
Okay. I got a couple more. Is that okay to continue the Q&A? We got a few more.
I have a yeah.
Do you have a hard stop?
Let's see if we can finish by 4 minutes.
Okay.
If not, please send me all the questions. I will answer offline.
Sure. So one of them says, your answer helped a lot. The last question is that if no one else has well, you said that the SQL engine has to choose from many different query plans and does its best to choose the best one, but it has a limited time for this process, right? Can we configure the SQL engine to take more time to build a higher qualified query plan?
Unfortunately, no. They have a hard-coded time. The time is dynamic, but it's hard-coded. So you cannot say I want to spend some time to find the best plan, right? But sometimes it's not worth it. Think about this, right? So the user to the application or to the user, is that which one is important for them, right? Spending more time to get a faster query plan, that saves them several seconds, or to get a good enough query plan and return the records quickly. You mostly, I would say the user prefer to get the data quickly.
Yeah,
Right?
there's always a trade-off, I guess, one way or another.
Yeah, that's true. So yeah, I think that not only SQL Server, in the last 5 years, I work very close with open source database developers. See several implementations of MySQL and Postgres, right? And they all take the same strategy, right? The good enough query plan is enough. They don't need to spend time to find a better one. But that another way to see that is that that's why sometimes you need to use the plan hints. The plan hints is different from query hints. Plan hints to guide it, the plan because you are very sure that the plan you different from the optimizer's results are better. So you can use the plan hints to guide the SQL Server to generate the plan you wanted.
Cool. Well, there's one more question. I don't know if you have time for it.
Sure.
So this one says, is it a good practice to truncate the table and populate the table during that, and then disable the index and then rebuild them? I guess,
Well,
you sort of answered it earlier, right?
yeah. Truncate table is if you have a staging, the table, the records are for staging purposes. Truncate definitely benefits you because when you do a truncate, it's a metadata level change. There is no deletion happen inside the storage, right? So that's faster. But I believe I already answered the question of the benefit to drop the existing index and rebuild when you have a high volume data loading, right? So
yeah, normally I would think that if you truncate and load, it's mostly for smaller tables. And then building index wouldn't take as much time, right? Yeah.
Yeah,
Okay.
one of the interesting observation is that a lot of performance issue happen on Monday morning, right? So why? Because most business choose the weekend to load in a high volume of data, and the common complaint is that it was working yesterday, it was working last Friday, right? So why it's not working? That is because of when you're loading the data, the statistics was not being triggered. Why? Because, for example, if you have 100 million rows, right, and last week only loaded about 1 million rows, new records, or updated, changed 1 million rows, and this one has not been triggered auto statistics. And on Monday, when you query the data. I know, for example, in the new data, I have a product new name is called Z1, right? I do not have before. I do not have the product names equal to Z1. Now I'm having a Z1. I want to query Z1, right? And because of the stats is old, the stats checked the statistics said I'm very sure I do not have any product name equal to Z1. Then what happened? The query plan will choose index scan or table scan, even worse, to scan the whole table. And then why that will cause you delay? Because it does not know that I have a record equal to Z1. In this case, you can use the query, the plan hints with the query, right? So the plan hints, I don't have time to talk about the plan hints,
Maybe
but the
next
plan
time.
maybe next time. The plan hints will tell the query when you see the value, use the query as if you have a query product name equal to A2, for example, and then no matter what the value you pass to, I want to search A1, the query plan will use the same plan when you query the A2. Maybe that time they will use the index seek, and the index seek will find the value quickly. But yeah, that is an advanced topic about use the plan hints. Yeah.
Cool. Yeah, I think we'll